Section 4.4, parallel and perpendicular lines. This lesson does not have an essential question. Essentially, it's a lesson that's going to review everything you need to know about parallel and perpendicular lines. All right, so write an equation for a line parallel and perpendicular to each given line. So I'm going to give you a line, and we're going to need to write an equation that would be parallel to this line, an equation that is perpendicular to this line. So first, let's remind ourselves what needs to happen in order for lines to be parallel or perpendicular. In order for lines to be parallel, they have to have the same slope. And in order for lines to be perpendicular, they have to have a flipped and changed slope. Okay, so let's look at the slope in our original equation. Y equals 3x minus 1. So in order for these lines to be parallel, they're going to have the same slope. So y equals 3. Now, parallel lines will have different y-intercepts, and really you can pick any y-intercept you want to. So let's just say plus 4. As long as your y-intercept isn't negative 1 again, that will work. All right, perpendicular. So I need to take 3, my slope, and flip and change it. 3 flipped and changed is negative 1/3. So my slope has to be negative 1/3. And for perpendicular, I can pick any y-intercept I want. Perpendicular lines can have the same y-intercept. Let's just choose a different one, just because. But perpendicular lines can have the same y-intercept. All right, so let's try another one. Y equals negative 2x plus 5. So my slope in this equation is negative 2. So a line parallel to it also needs to have a slope of negative 2. And then let's give ourselves a y-intercept. You can make up anything you want. We'll say plus 1. Now for a perpendicular line, we need to flip and change our slope. So negative 2 flipped and changed is 1/2. And let's give ourselves a y-intercept. We'll say plus 3. And one more. Y equals 2/3 x minus 4. So our slope is 2/3. So a line parallel to it has to have the same slope. And we'll say our y-intercept is 2. And our perpendicular line has to have a flipped and changed slope. So that'd be negative 3/2. We'll say negative 1 is our y-intercept. So the big thing when you're creating lines that are parallel or perpendicular is paying attention to those slopes. Parallel equations have to have the same slope. Perpendicular equations have to have a flipped and changed slope. All right. Determine whether the lines are parallel, perpendicular, or neither. So we're given 2 equations, and we have to figure out if they're parallel, perpendicular, or neither. Well, just like in the last slide, what we care about are the slopes. We have to know the slopes to determine if they're parallel, perpendicular, or neither. So let's get these equations in slope-intercept form. Right now they're not in slope-intercept form, so we don't know their slopes. You cannot look at these equations and determine if they're parallel or perpendicular without getting them in slope-intercept form first. Divide everything by 4. And we have y equals negative 3/4 x plus 3. So my slope in this equation is negative 3/4. So that's what I care about from this equation. I don't care about the y-intercept. I don't care about the plus 3. The only thing I care about is the negative 3/4. All right, let's do the same thing on this side. We have a negative 4x, so we have to add 4x this time. divide everything by 3. And again, all I care about is my slope. My slope in this equation is 4/3. So let's compare our two slopes. We have negative 3/4 and we have 4/3. Well, are these slopes the same? No. So these lines are not perpendicular. Are these slopes flipped and changed? Well, negative 3/4 flipped and changed is 4/3. So these lines are perpendicular.
Please turn your TVs to channel 67.
These lines are perpendicular. All right. Write an equation in slope-intercept form for the line that passes through negative 2, 3 and is parallel to the graph of y equals negative 3x plus 2. So let's look at what we're given here. So we're given the graph y equals negative 3x plus 2. And we're given a point. The point we're given is negative 2, 3. So we know that our new line has to go through this blue dot, which is negative 2, 3. Well, the other thing my line needs in order to be able to write an equation is a slope. So my slope in my original equation is negative 3, so a line parallel to it is also going to have a slope of negative 3. Let's take our point and our slope and put it in point slope form. And then we can solve it to get it into slope intercept form. So we have y equals negative 3x minus 3. Check and see, are our slopes the same? Yes. Negative 3 in my original line, negative 3 in my new line. And we can graph if we want to make sure it goes through that coordinate point, negative 2, 3. So rise negative 3, run 1. And we need to go backwards in order for it to go through our blue dot. But it does. There's a review of just parallel, and then we're going to review one final one with just perpendicular. So let's graph our original equation, y equals 1/3 x minus 2. And let's graph our ordered pair that our line needs to go through.
Excuse the interruption. Please hold on for the attendance for a few minutes.
All right.
There's still many cars
So
out
we
in
are
the parking
given
lot.
the
Thank
ordered
you.
pair of 2, negative 1, and our new line has to be perpendicular to the 1/3 x minus 2. So I have to flip and change 1/3, which 1/3 flipped and changed is negative 3. So that's going to be my new slope. So take your point and your slope, put it in point slope form, and then solve it to get it into slope intercept form, which is what they're asking for. Remember, a negative times a negative makes a positive, so it should be a positive 6. Alright, so our new equation is y equals negative 3x plus 5. Let's check our slopes. So 1/3 in the original, negative 3 in our new equation. So they are flipped and changed. It should be right. Let's graph it and see. Rise negative 3, run 1. Rise negative 3, run 1. And it does go through our red